Hi, this is Mrs. Kidman, and in this video, we are going to be discussing arc measure, arc length, and area of sectors. So all of this has to do with the arc measure of a circle. So what is an arc measure? Well, an arc measure relates the angle measurement that we have on the inside of the circle to the measurement of the arc on the outside. So remember that the internal degrees of any circle add up to 360 degrees, meaning that an arc measure just relates that measurement from the inside of the circle to the outside. So an arc measure is just going to be the same thing as the degrees of the internal angle that we're discussing. Internal angle. Okay, so then we have two different types of arcs that we actually deal with. We deal with one called a minor arc, and a minor arc is going to be the smaller arc. So in this case, in our image to the left, our minor arc is highlighted there in blue. A major arc is going to be the larger arc. And the larger arc is going to be this one on the outside here, where it actually goes around the outside of our circle. It'll look something like this. So that is our major versus our minor arcs. Now, depending on what we're trying to find when it comes to dealing with arc measure, we might be asked to find one or the other, but to find them is going to be exactly the same. So let's take a second to figure out what the measure of the following arcs are. So in this case, we want to figure out what the measure of RS is. Well, RS here is going to be this arc here. Now, the measure of an arc is exactly the same as the measure of the angle on the inside. So RS is going to be the same as that angle RPS, which is 110 degrees. Now, what if I wanted to find RTS? Well, that's going to be this outside angle, this outside arc, or the major arc. So to figure out that major arc, remember, the degrees around a circle is 360. So if our minor arc is 110, our major arc is just going to be 360 minus that 110, meaning that the measure of arc RTS is going to be 250 degrees because it's going all the way around the outside. The last piece that we want to figure out is what is the measure of arc RST. So what arc is that one talking about? Well, RST is going to be this arc here. You can see it in purple there. And so when it comes to finding the measure of that arc, we can see that TPR goes from one side of the circle all the way across to another point through the center point P. Because it goes through that center point P, that makes RT the diameter of the circle. And at the diameter of the circle, we've got 180 degrees on one side and 180 degrees on the other. It doesn't matter what circle we're dealing with there. So because it splits that measurement of arc RST is actually going to be 180 degrees as well because it's split up right there at our diameter. Let's take a look at another example here where we are looking more at these things. So in this next piece, we're talking about arc measure still, and we're dealing with the arc addition postulate. Now, these postulates and theorems that we're about to talk about are very straightforward. They're things that you're like, well, duh. And so we just want to cover them briefly so that we're aware of them before we go into talking about other things. So the arc addition postulate says that if I have the measurement of one arc, ABC, it's equal to the measurement of the two smaller arcs, the sum of them. Makes sense, right? Because think about how we calculate the measure of an arc. They're saying that the measurement of this arc, AB, is going to be added to the measure of the arc CB, and its total going to be the same as the measure of this whole thing. Well, because it's based on our angles, we have the angle addition postulate that says I can add one angle and the other one, and it's equal to the sum of the whole angle. And because that angle addition postulate works and the arcs are based directly on the angle addition, or arcs are based directly on angles, if we can add the angles and make the huge angle, then we can add the arcs and still get that same measurement. How cool is that? Okay, so that is postulate number one. Using that idea, let's figure out what the measures of these different arcs are. So we want to figure out what the measure of arc GE is. So we're going to go from here all the way around here. Well, by that arc addition postulate, I can add up the arc of GH plus the arc of HE. Well, GH is 40, HE is 80, so that means the measure of GE is going to be 120, or 40 plus 80. What about the measure of arc GEF? Well, going to GEF, we're going to go from here over to E, over to F. Well, we figured out what measure of GE was already. That's 120. Now we need to add in the arc from E to F, which is 110. So we've got 120 plus 110. So from G all the way to F is going to be 230 degrees. Okay, our last one that we're looking for is the measure of GF. Now the measure of GF is going to be this one on the back here. And there's actually two different ways that we can find it. We can try to figure out what that is using some other things, or we can say that that green was our major arc, and the relationship between the major arc and the minor arc is that they add up to 360. So I know that that green one plus the blue one need to equal 360. So I can just take 360, subtract out the measure of arc GEF, which is 230, and I can get that GF is equal to 130 degrees. Bam, there you go. Okay, let's talk about a few other interesting theorems. This next one makes a lot of sense. Just think about it. Congruent circles theorem. Two circles are congruent if they have the same radius. Well, who would have thought? Because how do we define what a circle is? Well, a circle is any point that's equidistant. It's created by taking one point and drawing all the points around it that are equidistance away. So if that equidistance is another way of talking about our radius, if two circles have the same radius or the same equidistance, then they have to be congruent. They have to be the same because they have the same radius. And think about how we measure a circle. To find the circumference of a circle, we do 2 times pi times r. Well, 2 is a constant, pi is a constant, so r is the only thing that changes. If they have the same r, their circumference is going to be the same. To figure out the area of a circle, we do pi times our radius squared. Again, pi is our constant, so whatever the radius is, if they're the same radius, the area is the same. If something has the same area and the same circumference, by golly, don't you think it's the same? Because doesn't that imply that it has to be the same? Yes. Okay, so there is that one. And then here's one more that kind of branches off of that. The congruent central angles theorem. So what this says is if we have two minor arcs that are congruent, then the two minor arcs are congruent if and only if their corresponding central angles are congruent. So what does that mean? If this is the same, then this has to be the same. If this is the same, then this has to be the same. Now, those minor arcs and those central angles will be the same, meaning that they have the same arc measure. However, in the next video, we are actually going to discuss what it means to find an arc length and the sector of an arc, or the sector of the area of a sector, I guess is the way you phrase that. But because we're talking about that, the minor arcs are congruent, meaning that their arc measures are congruent if, and only if, the angle measure is the corresponding central angles are congruent. So the arc measures are congruent if the central angle is congruent. That does not mean that the lengths are going to be congruent, however. So that is a couple of theorems related to arc measures and circles and all those cool things. Please check out the next video in which we discuss how we can calculate arc length, what it is, how it's important, and also check out the one following that where we talk about the area of a sector. If you have any questions, don't hesitate to reach out.